Today's topic is the torque that is experienced by electric dipole in a uniform electric field. You can look at this diagram. These parallel lines, these are showing the electric field. How we come to know that it is uniform? Sometimes the question used to come in the exam. Just looking at the figure, how you can mention that whether this is a uniform electric field or not. So when these lines are parallel and they are equidistant, then they form the uniform electric field. And this uniform electric field is external. In that external electric field, this dipole is being placed. Now, because of this dipole is going to experience a couple, and that will make this dipole to align in the electric field. Here, because of this electric field, plus q charge will experience the force QE, and that will be in the direction of the electric field. This minus q charge will experience the equal force, but that will be in the opposite direction. This is the direction of the force experienced by minus q, and this is the direction of the force experienced by plus q charge in the presence of this uniform electric field. The dipole is having the distance 2L between two of them. Now we can see electric dipole is placed in an external uniform field, that is E here. A couple acts on the dipole. This couple has a tendency to make this dipole to be in the direction of the electric field, and this is called the restoring couple because of its nature. Now, you can see here that this electric dipole placed in a uniform electric field, and due to this, the force exerted on charge plus q, already we have discussed, it is plus QE, and the force exerted on the charge minus q is minus QE. If you look at these, the net force that is acting on the dipole, that will be equal to 0. Because this net force is 0, there is no translating movement. The translating force is 0 and there won't be any movement over there. But here two equal and opposite forces are acting on the dipole, and they form a couple which exerts a torque. It means that translatory motion won't be there, because here in this direction and in this direction equal and opposite forces are acting, but rotatory motion will be there, because here the couple is formed in which two equal and opposite forces are acting on the dipole. The torque can be calculated by taking the product of either of the force and perpendicular distance between the two forces. Now we can look at the figure. If this dipole is making an angle theta with the electric field, then this is the perpendicular, this has been drawn. So this perpendicular distance will be 2L sine theta. Now we can place these values over the formula and rearranging, because q into 2L, this is our electric dipole moment denoted by P. So we have written PE sine theta. Now this torque is perpendicular to both the dipole moment as well as the electric field, and its direction is given by the right-handed screw that is being shown in the figure. So this torque is perpendicular to both dipole moment and the electric field. So we can write down the torque as the cross product of dipole moment and the electric field. Since torque is equal to cross product of dipole moment and electric field, so we can see that torque can have maximum or minimum value depending upon the angle at which the dipole is aligned with the electric field. If the dipole is released, the torque has a tendency to align the dipole in the direction of the electric field. In that case, the angle will be the 0 and torque will also be 0. It is clear that it is depending on this angle, and sine will be having maximum value when theta is 90 degree. It means when the dipole is perpendicular to the electric field. In that case, we have torque is equal to the product of dipole moment and electric field. One more important thing is here, if our electric field is 1 unit and angle is 90 degree, then torque is equal to dipole moment. Hence, one more definition comes out here, that dipole moment can be defined as torque acting on an electric dipole when it is placed perpendicular and the electric field is of unit strength of the value 1.